Okay, section 1.4 on functions. So a function is a relation that assigns to each element x in a set exactly one element y in another set. And all that means is that the x's cannot repeat in order for something to be a function. So for every x value, there is only one y value, not two different y's, not a positive and a negative, only one. Okay, so there's some ways that we represent a function. First is verbally through a sentence, numerically through a table or a list, graphically on a graph, and then algebraically in an equation. So we need to be able to recognize in all these different ways if something is a function or not. Function notation, when we take an equation like y equals 1 minus x squared and write it in function notation, we write it like this: f of x equals 1 minus x squared. And so this is a function of x. I'm going to plug in x values and I'm going to get an answer out. Okay, so then the domain of a function are the x values, it's the input, and also the independent variable. The range can be the y value or the output, and that is the dependent variable. So we're going to be asked to find the domain of a function, and what that means is to find the x values that you can plug into the function that will give you an answer. Not undefined, not an error. It's going to give us a numerical answer. So we have three different types of functions we're going to look at in this section. First is a polynomial function. And for a polynomial function, the domain is all real numbers. That means I can plug in any value that I want and I will get a numerical answer. Next is a rational function. A rational function looks like a fraction. It's got an x in the top and the bottom, or just in the bottom. And to find the domain of a rational function, we set the denominator equal to 0 and solve that equation. That will give us values that the domain cannot equal, because anytime the denominator is equal to 0, it's undefined. And then last is a radical function, which would be a square root function. And you set whatever is underneath the radical to greater than or equal to 0 and solve that. That will give you the domain for that function. Because for radicals, we don't want to take the square root of a negative number. We don't want what's underneath the radical to be negative. So when you set it greater than or equal to 0, that will ensure that it's always positive. So example 1 wants us to determine if the following represents a function. So we're going to look at a couple of different examples here. So first, I have a list of numbers, a list of ordered pairs, 5, 3, -2, 1, 6, 1, and 0, -3. So in a table or a list of numbers, we just need to look at the x values. If the x's repeat, it is not a function. So if I had 5, 3, and then 5, 1 in my list later, it would not be a function because the x's would be repeating. So this one is a function because the x's do not repeat. Okay, next we're going to look at a graph. If I have the graph of some equation, doesn't matter what the equation is, and I want to know if it's a function or not, I'm going to draw a vertical line somewhere on that graph. If your vertical line touches at more than one place, it's not a function. That would mean that the x's are repeating. These 3 points in the graph would all be the same x value and then different y values because they go up and down different amounts. So this one does not represent a function. And then C, if I have the equation y equals the square root of x plus 4, I can plug this into my calculator and I can go look at the graph and see that this one is a function. The x's would not repeat and it would pass the vertical line test. Okay, next we're going to look at how to evaluate a function. So for part A, I have the function f of x equals 5x squared plus 2x minus 1, and I want to find f of -1. So that means I'm going to plug in -1 everywhere there's an x in the function. So f of -1 is going to be 5 times -1 squared plus 2 times -1 minus 1. Then we're just going to go through and simplify. And remember to use order of operations. What's being squared in this equation is just the -1, not 5 times -1 and then squared. So when I square the -1, that's going to become a +1. So 5 times 1 plus 2 times -1 minus 1. Then we do all of our multiplication. So 5 times 1 is 5, 2 times -1 is -2, and then I have the -1 on the end. So order of operations, now I'm going to add left to right. 5 minus 2 minus 1 will be 2. So f of -1 equals 2. Make sure that you put f of -1 on the left-hand side, or it's not a complete sentence, not a complete statement. Okay, we're also going to be evaluating functions with expressions. So here I have f of x equals the absolute value of x squared minus 1, and I want to find f of x minus 1. So I'm going to plug in x minus 1 everywhere there's an x. So I have the absolute value of x minus 1 all squared minus 1. Now when you have a binomial squared, remember that something times itself. So x minus 1 times x minus 1, and then the minus 1 out at the end. So when I do the x minus 1 times itself, I actually need to FOIL that out or distribute, and that would be x squared minus 2x plus 1. And then I still have the minus 1 on the end. And then the only other thing that I can do inside is combine like terms. So the plus 1 minus 1 will actually cancel. So this is the absolute value of x squared minus 2x. I can't drop the absolute value bars because I don't have anything inside simplified further. If I had it down to a number, then I could take the absolute value. But when you have an expression inside, you just need to leave it like this. Okay, and last we're going to look at the domain of the function. So this first one, f of x equals 1 over x squared minus 4. This is a rational function because it looks like a fraction. It's got x's in the top and bottom or just in the bottom. So for a rational function, we set the denominator equal to 0 and solve. So x squared minus 4 equal to 0. I'm going to add 4 to both sides. So x squared equals 4. Then I would need to take the square root of both sides. And remember, when you take the square root, it's the positive and negative square root of 4. So that means it's going to be the positive and negative 2. So our domain for this function is all real numbers except 2 and negative 2. That means I could plug in any number I wanted to into this function and it would give me a value except for 2 and negative 2. Those would make the denominator equal to 0 and it would be undefined. Okay, so the next one is f of x equals the square root of 3x or 2x plus 3. So this is a radical function. For a radical function, you're going to take what's underneath the square root and you're going to set it greater than or equal to 0. And we're going to solve this. So I would subtract 3 on both sides. So 2x is greater than or equal to negative 3, and then divide by 2. So x is greater than or equal to negative 3 over 2. So the domain for this radical function means I can plug in any number that's bigger than or equal to negative 3 over 2, and it would give me a value. If I plugged in anything less than negative 3 over 2, I would have an imaginary number, and we're not talking about those yet. So the domain is x is greater than or equal to negative 3 over 2. And then last, f of x equals 5/3 x. So I know this has a fraction in it, so you might think it's a rational function, but the x is not in the fraction. It's 5/3 times x. So this is actually a polynomial function. And the domain for a polynomial function is all real numbers. I can plug in any number that I want for x, and it's always going to give me a real answer.